Hi, in this video I'm going to show you how do we find horizontal asymptote and oblique asymptote. Okay, so keep this in mind. If a function has horizontal asymptote, then it will not have oblique asymptote. Similarly, if a function has oblique asymptote, so it will not have horizontal asymptote. Okay, the next thing we do is how do we find those? So it depends on the degrees of top and bottom of a rational functions. Okay, so the rule number one is if degrees of the numerator, the top function, degree of the top function is smaller than the degree of the bottom function, degree of the denominator, then there is only horizontal asymptote, no oblique asymptote in that case, right? But what is that horizontal asymptote? The horizontal asymptote will be y equals to 0 for any problem. Okay, if the top degree is less than the bottom degree, then there will be just horizontal asymptote, and that will be given by y equals to 0. Let's take an example. Example number 1. What is the degree of the top? It is 2. The degree is basically the highest coefficient. Okay, what is the degrees of the bottom? It is 3. So the top degree is less than the bottom degree, so it has only horizontal asymptote, and as we mentioned in rule 1, the horizontal asymptote is y equals to 0. Done. Okay, how about the second problem? The degree of the top is 2 and the degree of the bottom is 2. Actually they have equal degree, so we cannot use rule number 1. So let's go to rule number 2. Rule number 2 says that if the degree of the top, degree of the numerator, is equal to the degree of the denominator, then there will be just horizontal asymptote, no oblique asymptote, only horizontal asymptote, and that will be given by y equals to ratio of the leading terms. Okay, let's do that. The degree of the top is 2, the degree of the bottom is 2 again, so they have the equal degrees. Okay, so how do we find the horizontal asymptote? You write y equals to the ratio of the leading terms. What do you mean by leading term? Leading term is the degree, or leading term is the highest degree term. So here this is the highest degree term. It will be 2x squared divided by the highest degree term here is 3x squared, right? You cancel x squared and x squared, so what do you get? You get y equals to 2/3. So this is the horizontal asymptote. Okay, sometimes though you will have to FOIL the top and bottom to find out the leading term. For example, here what is the degree of the top? So the first factor has degree 1 because the highest exponent is 1. The second factor has degree 1 as well, but these two factors are multiplied, meaning the degree will be added. So the top has 1 plus 1 degree, that is degree 2. The bottom has, this has degree 1, this has degree 1. So the top and bottom has degree 2. So they have equal degrees. So how do we find the asymptote then? We write y equals to ratio of the leading terms. So if you FOIL the top, what do you get the leading term? So the leading term will be the term with highest exponent. So when you multiply 2x and 3x, that will have the highest exponent. That will be the exponent will be 2, right? So like 6x squared divided by, so here the 3x and here x. So they have both x, right? If you multiply, you will get x squared. That will be the highest degree term after you FOIL it. So how much is that? Negative 3x squared will be the leading term after you FOIL it. Okay, you can FOIL one by one and then you can see that the highest degree terms are those terms. You can do that, but if after you cancel that, you will get 6 over negative 3 is negative 2, right? So y equals to negative 2 is the horizontal asymptote. Alright, so meaning that if the degree of the top and the degree of the bottom are equal, then you take y equals to the ratio of the leading term, or you can say the ratio of the leading coefficients will be the horizontal asymptote. In that case, there is no oblique asymptote. And the formula number 3 is if degree of the numerator is equals to the degree of the denominator plus 1. What does that mean? If the numerator degree is 1 more than the denominator degree, right? In that case, there is only oblique asymptote. There will be no horizontal asymptote in that case, right? But how do we find that oblique asymptote? What you do is y equals to the quotient. When you divide the top by the bottom, and then whatever quotient you get, y equals to that quotient will be the oblique asymptote. Okay, let's find out the oblique asymptote in this case, because the degree of the top is 2, the degree of the bottom is 1, the degree of the top is 1 more than the degrees of the bottom. Okay, so in this case there is oblique asymptote. So to find out the oblique asymptote, let's do the long division. Let's perform the long division, and then whatever quotient we get, y equals to that will be the oblique asymptote. Let's do that. So we are dividing x squared by 2x minus 3. You guys know how to divide, how to perform a long division. What you do is divide the first term, the highest degree term, by the first term of the divisor, like x squared divided by 2x. What do you get? So it is like x times x over 2x. So you cancel x and x, you got x over 2. So you write x over 2 on the quotient. Now what you do after that is you multiply this x over 2 to each of those. So what do you get? X over 2 times twice x will be 2 and 2 will cancel, right? So it will be like x squared, and x over 2 times negative 3 will be negative 3x over 2, right? Now you subtract x squared from x squared. Okay, so it will be like, subtract means change the sign, so that will be 0, and this is positive 3x over 2, or 3/2 x. Is it still divisible by 2x? Yes. So what you do next is you divide 3x divide 2 whole divided by 2x. What do you get? You cancel x and x, and then 3/2 divide 2. You can use calculator to do that. So 3/2 divide 2 will be 3/4, because it is like 3/2 divided by 2 over 1, and then you can write 3/2 times 1/2. When you write the division into multiplication, you multiply by the reciprocal of the denominator fraction, right? So basically it will be 3/4. So you write plus 3/4. Okay, now that's the quotient you got, and then you multiply that 3/4 with each of those, and then write down here. So 3/4 times 2x will be, so you can show it here, 3/4 times 2x will be, you divide by 2 will be 2, and 3/2 x, right? 3x over 2, that is 3/2 x, 3/2 x, and then 3/4 times negative 3 will be minus 9/4, right? You subtract again, you subtract will cancel, plus, so the remainder is 9/4. We don't care the remainder though, we just need the quotient. Okay, after the division is complete, you write the y equals to the quotient is the oblique asymptote. So what is the answer then? The oblique asymptote here is y equals to x over 2 plus 3/4. In fact, you can figure out those horizontal, vertical, or the oblique asymptote from the graph as well. You can estimate those. Okay, if you plug in these functions, these or that or that or that function in the graph, you can see that if there is a vertical asymptote, you can see like a blow up somewhere in the towards the vertical line, right? That means, like, have you seen the electrocardiogram, like that type of behavior? If you see the blows up, that must be the vertical asymptote, right? And for the horizontal asymptote, you can see that the curve will show like smooth behavior, and then it goes to a horizontal line. That will be the horizontal asymptote. Okay, you can estimate from the graph as well. Similarly for the vertical, for the oblique asymptote as well. Okay.